So now I get to introduce Natalie. I asked for a bit of a CV and something to say, and most people would send you, 10 or 20 pages. I got something like 6 lines. So, the 6-line version, glasses on. When we first sent these out, she was just Natalie Rens. She's now Dr. Natalie Rens, so as of 5 days ago. The scary thing, her PhD is in neuroscience. She might understand why I shop. But she's now the Artificial Intelligence Specialist for the Office of the Queensland Chief Entrepreneur. So she's working on strategies to advance Queensland by improving the adoption of AI. She's also the co-founder of a makeup group, and she's passionate about democratising emerging technology to enable better solutions. So, as most of you know, comes to technology, I'm a real Luddite, so I'm really looking forward to this. I still aim to be able to turn my TV set on without asking my 12-year-old grandson how to do it, but just as well I'm not really into TV. A little bit more about Natalie, because that's a bit boring. Someone asked her before, her accent, where is she from? And they guessed somewhere in North America. That's only part of the mix. It starts off in South Africa. It includes North America and a move to New Zealand and a master's in England or France and Portugal. And then there's a few other countries thrown in. So while she looks about 15, she's actually done a little bit more than that. So I'm really looking forward to her talk tonight. So I'm going to just hand over to Natalie, and I'm really looking forward to it. So thanks, Natalie.
Thank you for the introduction. I should just also clarify, I don't run a makeup group. I run a Brisbane AI, which is a meetup group. As it's been mentioned, I've actually not come from artificial intelligence. I've come from neuroscience, which is how I got interested in this topic. But I know that probably like many others, this is a kind of new thing for everyone. So I just want to first get a hands up. Who is a little bit uncertain what AI is? No? Who really, really knows what AI is? Yeah. So for me, I did biomedical science and then I did neuroscience. I traveled a little bit around the world because I was really gypsy-like. And then I first discovered AI through machine learning when I saw this video. And this was researchers who were looking at brain activity in the visual cortex, and they're using these Bayesian statistical methods to try to decode what type of activity was being presented. So if they're looking at a human participant, what video were they actually seeing? And as you can see, on the left we have the original video, and on the right we have basically what they've managed to reconstruct from neural activity, so from the firing patterns of neurons in the brain. And it's not perfect, but it's pretty cool. See, they've even managed to get a face. So with that in mind, I went off and I did my PhD, and at the same time, I gallivanted around the world a little bit more, and at one point I ended up in Silicon Valley, which everyone knows is the heart of startups. And I went to Google and I saw Facebook and I met with a bunch of really incredible people there. And what really came to a point during that trip was this conference, which was based on emerging technology of the future. And this was a collection of academics and people working at technology companies and engineers. And it was a discussion about where are we actually going in society. And the biggest point of that discussion was what a huge impact artificial intelligence was going to have, and not only for people who are working in these companies, but for every single person. And the type of change was going to literally change the face of society. And we discussed this, we discussed all these impacts, and it came to this question at the end: what happens when artificial intelligence sits in the hands of just a few? So what happens if nobody's actually aware of what's happening and only Google has artificial intelligence? This is not a world we really want to see. So I came back to Brisbane on a bit of a mission. I started Brisbane AI, which is a meetup group. We now have think 1,400 members, and we run events. We just try to, I guess, educate and bring to light the really cool things that are happening in AI. And as a result of that work, I'm now working on AI strategy with the Office of the Queensland Chief Entrepreneur, which is a very strange office that works on innovation, basically. So today, I'd like to keep it fairly informal. If anybody has a burning question, like, please interrupt me. But I really just want to impart what AI is and why I find it really exciting. So to start, you may not be aware, but AI is actually quite old. So this is the original brief, which you probably can't read, which came out in 1956. And this was a professor called John McCarthy who ran a summer camp. And he was saying, we're going to get together 10 researchers for 2 months, and we're going to work on how to make machines use language, form abstractions and concepts, solve the kinds of problems now reserved for humans, and improve themselves. So 2 months to figure this out. Very little did he know that 60 years on, we would only now be getting to really take all of these aspects to fruition. And the reason we've managed to do this is a series of 3 points. So we've had an explosion in the amount of data that we collect about people and the amount that we're able to store. We've had an increase in computational power, which was actually brought about by the gaming industry and the development of these GPU chips. And thirdly, we've obviously improved the algorithms and our understanding of computational networks. So where we're at right now is narrow intelligence. And what this means is that we can take an artificial intelligence algorithm, we can train it to, for example, play chess, and it's going to be amazing at chess, better than a human. But it can't, for example, play a piano. It doesn't have this level of broad or general intelligence that a human does. And within this, we also have a lot of different domains. So we have things like computer vision, robotics, expert systems. These are the types that would learn chess, speech and natural language processing. And then where we've actually seen this massive improvement in the last 5-10 years is in this very, very top branch, which you can't see, which is machine learning and deep learning. So to briefly just define what these terms are, I know that they're thrown around a lot, and you probably read them in a lot of media. Artificial intelligence is computer systems which are able to perform tasks that humans would normally do in an intelligent manner. Out of artificial intelligence, we then have machine learning, which is pretty self-explanatory. It's a machine that is able to learn something without being explicitly programmed. And then within machine learning, we now get to deep learning. And this is where we're seeing these huge breakthroughs at the moment. And deep learning is just a type of machine learning where we use artificial neural networks, which is a brain-inspired architecture. And they have more than 2 layers, hidden layers. So I'm just going to go through what AI is in 4 slides. Hopefully that gets it across if anybody's uncertain. So if you think about a normal computation or you have a calculator, what you would normally ask is, for example, you want to do 4 plus 3. What this equates to is you're saying, I know the inputs that I want to give you, it's 4 and 3. I know what function I want you to perform for me. In this case, it's an addition. And then I'm asking the computer to give me the output, a 7. When we get to machine learning, we flip this. We say, I know the inputs I have, 4 and 3. I know that I want to get to a 7. You figure out the rest for me. In this case, obviously, would figure out an addition. This isn't particularly interesting. Real-world problems, we can get to better associations. So you can say, every time I see this really cute kitten, I'm going to see a happy baby. Every time there's no kitten, I'm going to have a sad baby. And you would give lots and lots of examples of kittens and happy babies and no kittens and sad babies. And the machine would actually learn that every time you see a kitten, you're now going to end up with a happy baby. And a more practical example, this is how your spam filter on your email works. So you learn to associate specific words with spam, specific other words with not spam. So every time you see Nigeria and money, suddenly you have spam, right? What about if you actually wanted to be able to look at this kitten and say, this is a kitten or a cat? That becomes a lot harder because to be able to perceive that is an insane amount of work. In our own brains, it takes multiple layers of networks. And what a machine actually sees is these numbers. So it sees a matrix of pixel values, essentially. And so to be able to get from this entire matrix of numbers to cat is hard. You can't just do a simple probabilistic mapping. And this is where, at least in computer vision, we've turned to what the human brain does. So if you look at a cat, it'll go through your eyes into your visual cortex, and it will pass through these series of neurons until it gets to what you have as an abstract representation of a cat. And each of those neurons changes a little bit or has a different output at the end of it. So for example, the first layer of neurons will be able to tell where the edges of a cat are, and it will tell horizontal lines, or vertical lines, diagonal lines. The next layer will be able to figure out that there's noses, and finally, once you've added this all together, you get to what a cat is. So we've taken exactly this principle, simplified it, and what we now have are neural networks. And this is the entire premise of today's learning, where we're having these breakthroughs. And the deep learning part is simply that we have multiple layers here. So again, we have an input, a certain number. You manipulate it every time, and you get to the output. And that is essentially what is driving most of the world today. And it doesn't have to be just computer vision. We don't really just want to look at cats all the time. Another aspect that we have seen a lot of advancements in, has anyone heard of AlphaGo? Yep, one. That's two. That's pretty cool. Oh. Cool. So AlphaGo is a computer program that's managed to beat Go Player, the best Go player in the world. And Go Player is a game where there are just far too many moves possible for you to actually be able to figure out. So it's been pretty nuts. And then very recently, OpenAI also had Dota, which is a war-like computer game, which again managed to beat the best Dota players in the world. And these type of successes rely on this idea of deep reinforcement learning. And this comes from, again, something we've learned from behavioral science. So if you think of a child, and a child is learning, every time it does something really good, you give it a gold star or a pat on the back. You reinforce that behavior. If it does something bad, you punish them. And we can do the same thing with computer algorithms. So for example, we can take basically a skeleton of what a human body would look like. We can say every single time you get to the end of a race course or whatever course you've given it, you're going to get a lot of points. Every time you fall off, you're going to be punished. And then you just let it go thousands and thousands of times, trying out different combinations and getting better until you get to the end. And what we see with Google DeepMind is this. So this hasn't been told how to run. It's literally just been given a configuration, and it's trying to get to the end. What's pretty cool is that this one here, it's never seen this terrain, and it still manages to do pretty well. It still has like a spastic arm going on, but so yeah, those are some of the types of AI which we have now. But there's one common thing, and I think if you go out in the world today and you look about to see where there's opportunities for AI, one thing to just think is all you're doing is finding patterns in data. As soon as you have lots of data, it makes it easier because you have a lot of opportunity to learn and adjust and learn and adjust until you get to a point you know what's happening. So I wanted to briefly touch on some of the applications of artificial intelligence. And I believe you come from quite different backgrounds, so you're running businesses in various fields. So I've chosen healthcare, finance, and education just as separate industries, which regardless of whether you're actually in them, they will impact you in some way or other. So I want to talk some of the applications we have now, especially that are going on in Queensland, and also where this could be going in terms of future directions. So as we pointed out before, AI basically thrives on data. If you think about healthcare system, you have a lot of data about what type of medication works for people, what type of illnesses everyone has, but also your entire demographic background. And you can feed this to basically make diagnosis and treatment a lot better and personalized. So I don't know why this doesn't work on the thing, but if you see that little black blob just there, does anyone know what this means? Where that arrow points? So it actually means prostate cancer. And it's pretty hard to spot unless you're really, really well trained to do this. And then even if you are really well trained, it's still hard to spot. But we actually have a startup called Maxwell MRI in Brisbane who's developing automated prostate cancer diagnosis. So they're using computer vision, they're taking thousands of pictures of MRI scans of what prostate cancer looks like or doesn't look like, and they're feeding this in to basically create a system which can one day sit on an app. The same thing here. Does anyone want to hazard a guess at which panel, the top or the bottom, is melanoma and which one is benign? So who thinks the top is melanoma? Put it, yeah? What about the bottom? It's about 50-50, so it's pretty hard. But AI can do this. So the top is benign, the bottom is malignant. And recently, just released from Stanford, they have managed to train an algorithm, compare it to 21 of the top dermatologists, and they have 91% sensitivity, which means that it doesn't get false positives or false negatives in comparison. So it's pretty cool. And if you think about where we're going with this, at the moment, it's like if you, I don't know, you see a mole on your arm, you're like, do I really want to go to a doctor, check this out? It's like, maybe it's okay, or maybe I'll just watch it, I don't know. What you'll actually be able to do is just take an app, take a picture of your arm, and it's going to be able to tell you, actually, you're fine, or you should go see somebody about this. So we're really getting to this idea of having healthcare in a pocket and being more proactive about what we have happening to our own bodies. Something I also think is really fascinating is this human diagnosis project. And this came out of the poorer socioeconomic areas of America where they didn't have the finances to be able to go and see specialists. So what they would do is they would go to a GP, they would take a picture, for example, they had a rash, they would put some of the symptoms in, and then they would crowdsource this to other clinicians in the country who would then be able to answer. And what you see here is basically responses for myocardial infarction, so that people have actually generated from across the world. But while you're doing this, you're actually also developing a database so that one day you can again scan in what you have, and it'll be able to detect every other type of instance that has occurred before and diagnose for you. If we're thinking about future hospital, we also have really rapid advances. This is Hurston Biofabrication Institute, which is actually opening in Queensland in the coming years. They've set an entire future technology suite. So the premise is, let's say you happen to fall and somehow gash and break your entire leg. While you're in the ambulance on the way to the hospital, what will be happening is you'll have a full body scan, you'll have all of your data collected, you'll then have a extraction of all of your patient records, all of your background diagnoses fitting into a system so that by the time that you arrive in the hospital, they know exactly what to do. They can biofabricate with 3D printing a new, for example, shin for you. They can use a robotic arm that has used AI to develop the best ways to precisely get to the points that it needs to. They have a VR suite so that you can overlay the images, for example, like the internal images of your leg while you're performing surgery. And you can even have something like a smart table so that it knows exactly how to adjust the temperature or the parameters to keep you healthy and alive. And this isn't particularly the future, it's actually happening right now. So moving on to finance, we can see similar applications in the terms that we just take a lot of data which we know that we've already collected. We have a lot of transactions that everyone performs every day. And we can use this to actually personalize and create better financial systems. People might not realize right now, if you use MasterCard, you actually really have artificial intelligence driving your credit card, because it'll perform the fraud detection for you. And the way that it manages to do this is it actually learns exactly how you shop, your spending patterns, and where you shop. And then it manages, by doing this, to then detect when there is any anomalies, so you can have better, I guess, fraud detection, but also not have an aberrant fraud detection where it declines your card randomly. And this same premise of being able to personalize a fingerprint of a user is used in other things like cybersecurity. So right now, protecting your computer right now from hackers is a very similar mechanism, where it knows exactly how you use your computer, and as soon as somebody uses it a little bit differently, it sends an alert. We're also getting personalized finance. So this company, Acorns, is another Australian company which has developed an app for microfinancing. And this does a similar thing. It learns what your kind of spending behaviors are, and then it can project where you're likely to be in future in terms of bank balance. But it can also start to coach you. So if it sees that you're suddenly spending a lot of money on shoes, it can be like, oh, wait. Exactly, husband in a pocket. And they're using another form. They're also using natural language processing to be able to tailor that kind of communication exactly to how they think you're going to best respond to it. So it could be like, stop, walk away from the shoes. Or it could be like, think about your grandkids. And that will learn over time to actually do this. So in terms of future banking, I hope none of you are bankers, because the projection is that they're not really necessarily going to exist, at least not as banks. Yay. Oh. This is a video that PwC made about where we're going to be going in future. And obviously banking is going to be completely necessary for as long as we live, but it's likely to be very mobile. In this case, the simulation they portray is that you have this little chip, I have no idea how this would work, on your arm, and it pops up immediately because it's managed to match a perfect mortgage to what it thinks that your personality is. And this is essentially where we'll be going. Nobody really wants to make all these decisions about money, but we can offload this to AI to help us make our own decisions. So in education, we have massive disruptions, both in the fact that AI will change what our curriculum is. We need to be preparing kids for a very different future. But it also has the potential to really augment how kids learn, or how anybody learns. Ugh. Okay, you can't read that. But this comes from a forum in Georgia State University. So a student has asked, should we be aiming for 1,000 words or 2,000 words? And the teacher assistant, Jill Watson, has responded, there isn't a word limit, but we will grade on both depth and succinctness. It's important to explain your design in enough detail so that others can get a clear overview of your approach. It's also important to keep things clear and short. Someone said, I'm getting to wonder if Jill is a computer. They're right. So this professor at Georgia State got fed up with answering questions from his students, and he wrote a chatbot to answer for him. He trained it on all of his previous semesters, and then if it was 97% confident, it would then respond to the student. They didn't realize until the exam at the end of the semester that this is what he'd done. So I'm sure there's some of you that can relate to this. We've got similar approaches occurring where we now have automated grading. So we can grade not only exams, but we're at the point that we can grade essays for students. And this is at about an 80-90% comparison to what a human marker would give. So we apply a very similar approach where we take all of the essays people have written before, and we feed it what grade they've been given for that. And then we get computer to do the same thing. We also have intelligent tutoring systems. So if you use a MOOC online, this is likely to have some aspect built in. So it can learn what kind of level you're at in terms of the course curriculum, but it can also start to tailor it according to your own learning styles. The reason this is really great is because it means that you can be anywhere, and it can be actually teaching you at a level which is adapted to you as a person or as a child. If we take this into a classroom, we can have similar things, but we can also have it on robots. So we can have interactions with intelligent robots which adapt with you. You can even get to the point that you have one robot per child, for example, which knows exactly what the strength of that child is and can follow it throughout the classrooms each year, rather than a teacher having to try to learn 30, 40 kids at a time and all of their unique aspects. What we hope this does is it actually allows more time for teachers to do the real teaching. So if you have students guided on their own paths, if you have the really mundane tasks like grading dedicated to an AI aid, basically, you then can have a teacher which comes around each student and works with them. And in terms of future of learning, I think the thing that I find most fascinating is this idea that no matter who you are, whether you're a child, whether you're a senior, whether you're actually in a different country, you now have a lot of education accessible to you online. Not only is it accessible, but it will be tailored exactly to the way that you want to learn. And this is going to become even more important in the next few years as we shift through, I think on average, 7 different types of careers, and we have to learn all these new skills constantly. So I've spoken through a few of the industries where they're at in terms of applications and future directions. I just wanted to sum up with some of the trends that we see throughout these. And the first point to address, because it always comes out, is that we're not going to all be out of jobs. So the most recent analysis does say 20% are at high risk of automation. And this is actually down from 47%, which has been going around for the last decade or so. Those jobs are things that you can probably guess. They're the production lines in factories, heavy construction focused jobs, and administration jobs. What we actually see is also a 10% predicted increase in demand for some of the jobs which already exist. And these are in the ones which tend to be more technical, but or also have a stronger human factor. So they're healthcare, education, STEM jobs, so engineering, science, and then management, business, and finance, which is great for you guys. There's also the jobs that we never think about that didn't exist and will exist in the future. And it's always harder to try to imagine things that we had never seen before. But even things today like social media manager, this didn't exist 5 years ago. In future, we'll have things like human values alignment to make sure that the robots and the artificial intelligence algorithms that we're training are actually the best for humans. We'll have ethical officers in the same way, robot liaison. Those are just a few. I'm sure people can think of more. For the most part, and even for those 70% of other jobs that are there, what we're actually going to see is, rather than a complete replacement, is a collaboration between human and machine. So even if you think about the healthcare system where you're using AI to help you diagnose patients and provide more care, in education where you're using AI to help you grade and then again provide more one-on-one time, what we're actually going to be able to see is AI takes over on the menial tasks we don't want to do, and we'll be freed up to do the more exciting aspects that we actually want to do in the first place. We also, in terms of work, see this rise of the individual. So if you think about 50 years ago, most of the companies were these Fortune 500, so massive companies which you needed because you needed to have 50 people dedicated to finance and 50 people dedicated to marketing. Nowadays, we have a lot more startups, we have a lot more small businesses. If you think of Alibaba, which is probably one of the biggest companies that's now come out of China, they basically run on this premise that a small farmer in China should be able to sell their goods to any person in the world, and he shouldn't be limited in what he can do. And the reason that you can do this is because you have artificial intelligence and automation, which helps you. It helps you to pick your marketplace, and it helps you to do your personalized financing and sales. And this brings me to the fact that everything will be personalized. So in terms of the customer, I don't want to have to make decisions. I don't want to be treated just like the person next to me. And we're really entering the age now where everything can be tailored exactly to the way that I want to experience it. And me sitting here means that I can also buy anything from anywhere in the world, maybe not even have to think about what it is I want to buy, because those decisions will be helped by the use of AI. And finally, it's important to realize that things are very, very rapidly advancing. So they say that we're now at the fastest rate of change that we've ever seen, but the slowest we will ever see again. And my one call to action is really, if you're thinking about using this or you're thinking about things that you need to be doing, I would start them now. AI in particular, everyone thinks maybe or is a little bit unsure about it, but it's not like anybody else really knows because it is such a young field. There are a lot of online courses. As we've mentioned, you can basically find any MOOCs online to do this. And there's a lot of people around who are just learning as they go. So if I had one thing across, it is hopefully you really didn't think this, but this is not AI. What artificial intelligence really is all of these things which we already see around us. So we have art. So this is Van Gogh applied to Mona Lisa with art. Artificial intelligence. Google, Netflix, Facebook, all the ways that you manage to get the best movies to see, or you manage to get the search that you want. Drones, autonomous vehicles, and then what we've seen already with healthcare, finance, and education. And throughout all of this, as amazing as we have in these advances in AI, what is actually more exciting about it is that we come into this era where, as John Naisbitt says, the most exciting breakthroughs of the 21st century will not occur because of technology, but because of an expanding concept of what it means to be human. So this will enable us to actually do more of the things that we enjoy as human beings. So, thank you.